Hello everyone. I am here in this video. I'm going to teach you about the simulation of parallel plate using parallel plate capacitor using the finite element method, that is software. This is FEMM 4.2 package, that is finite element method magnetics 4.2, you can download it as a student version in the internet itself. It is freely available. And this simulation software will help us to understand and analyze the characteristics of electric fields, equipotential lines, capacitance, and to the extent of magnetostatics also. So you can simulate electrostatics and magnetostatic problems using this tool, and you can get a pictorial understanding about what you are studying in theory, and you'll get an in-depth analysis of the performance of various electrical devices, the influence of electrical fields on various electrical devices. So this is this is in this session I'm going to teach you about the simulation of a parallel plate capacitor, and of course there are many more combinations of things we can do it. So because it's just an introduction, I'm going to teach you only about the parallel plate capacitor. So other things, so we will learn while practical classes are going. Okay, so in this, what we are going to do here is, what we are going to do is we are going to open the FEMM package. So type the FEMM here. FEMM 4.2 is coming, and then select it. Now we get a screen like this. So click the new button. So to create a new project, and here you have to select which type of problem you want. So here you see there are 4 kinds of problems you can simulate using this FEMM 4.2: magnetics problem, electrostatics, heat flow, and then thermal and current flow problems. So here to start with, we are going to use the electrostatic problem and select the electrostatic problem and click OK. Now this is coming here. So this is about this. This is just introduction here. So open the software. So create a new project, and then select electrostatic problem. You'll get a screen with grid. That's what is available here. This is the screen with grid. Okay. So this is a plain grid. Now we are going to simulate. We are going to design the things. So first step is we have to create or construct a model. So what we have to do is to create a model. These are the steps. First thing is click problem in the toolbar, and once you click the problem definition, there is a pop-up menu will come, a box will come in which you get a problem definition, and from the problem definition you have to carry out these 3 things. So that is, you have to select the type of problem, you have to select the units, that is inches or in centimeters or millimeters, whatever units you want to use it, and then you have to fill the depth length. Okay, now you go to the software. So this here is, so here you see that this is the thing. So go to the problem. So now this is the problem definition is popping up. So here there are 2 types of types. One is a planar type, another one is an axis symmetric type. So in the planar, so here for now in this, for parallel plate capacitor, we are going to choose the planar type, and you can choose the type of whether the dimensions you are going to mention are inches or millimeters or centimeters, whatever it is. So we'll keep it as inches. You can keep the depth. Depth means, for example, if it is a cable, means what is the length of the cable. That we call it as the depth here. If the capacitance is what is the width of the parallel plates. That is the width, not the gap between the parallel plates. So we have the width. So that we call it as width. Now we keep 10 inches. That's sufficient depth. Okay. Now it's complete and we'll click OK. Now this part of problem identification and definition is over. Now coming to this. Okay, then next click OK, then it is OK. Fine. Now we have to go for the model construction. So a parallel plate capacitor is equivalent to a rectangular box. So what you have to do is, you have to do a rectangular box. So these are the steps we have to do. These are the steps involved in drawing the rectangular box. You have to mark 4 nodal points or 4 corner points at 4 corners of the rectangle, and you have to connect all the 4 corners using the line tool. From the line tool, so you have 4 lines. The top and the bottom line are considered as conductors, and the space in between the top and bottom lines will be considered as a dielectrics. So now we come to this tool. So here is the nodal point. So I keep 4 nodes here, and here. Now it's okay. Now I have to draw the lines. This is the line. Here, this is another conductor. Now I have to close it, so I cannot open it. Have an open boundary to get the solution. So it's over. So the rectangular box is over. Okay. So in between space, you have to keep it as a dielectrics. So this part is okay. And now coming to the screen. So the next what you have to do is, okay, let's look into the steps. Okay. So now we have to define the conductors. So we know that the top line is the conductor and the bottom line is the ground. But the software we have to feed it. We have to consider our simulation tool to consider which one is connector and which one is going to be the ground. So what I have to do? So these are the steps. Just look into the steps, and now we go to the software tool, and I'll teach you here. So here coming to the software. So go to these properties. So here there are many things. So now you have to choose the conductor. So in the conductor, add property. So we have to give the name as conductor, or you can give the conductor. And now what should be the, if it is a conductor, what should be this voltage level? So you can keep the voltage level you want to add. So I keep it as 100 volts. Put it as 100 volts. Now it is okay. Now the conductor is safe. So this is only for the top line. And now I have to add the ground. And ground is also a conductor. Click add property and give the name as G and D, which means ground, and give the prescribed voltage as 0 since it is a ground. That's okay. Now the conductors are marked. Okay. Now click everything is fine. Again, go to the properties, select boundary and add property. So here you can have new boundary. So we have to click mixed boundary. So this is the second thing. After defining the conductors, you have to define the boundary. This is okay. Now it is fine. Now the space in between, we call it as the dielectric material. How to choose the dielectrics? So again, go to the properties. There is a materials library. In the materials library, we have many numbers of dielectric materials. So I want to choose air as a dielectric, will bring it down. You can keep mica as a dielectric, will bring it here. You can use nylon, you can use paper, you can use the low density polyethylene or high density polyethylene. There are many materials. Which material you want to choose, you have to bring it down. So otherwise take it out. Okay, that's all. So now you have 4-5 options. You can choose any materials, you can choose the right material which you want to add it. Suppose you want to add a material which is not available in the library, means you just click the materials. Now click add property. So you make it as new material 1 and put your dielectrics value as 100 or whatever it is, the value of the dielectric material, dielectric constant of the given the new material you want to feed up. So for example, you have invented a new material for which the dielectric constant is around 100, and you can add it here like this. You can choose the new materials, and this is how you have to choose the new material. So now, we have defined the conductors, we have defined the boundary, we have defined the dielectric materials also. So this is the thing. So the thing is, how to define a conductor. So here are the steps. You go to the property, in the pop-up box, type the conductor name, mention its prescribed voltage, and click OK. And now again add property, go to type Select type it as a ground conductor and keep the voltage level of the ground conductor as 0. And now the conductor definition is okay. And now go to the properties, select library. So you have a list, you have a big list of materials available, and you choose the material you want to use, drag it to the next box, it will be added to the thing. And if you want to add your own new material, go to the properties. So in which click the materials. So again click add property. So where you have to type the name of the new material and its relative permittivity or dielectric constant, otherwise called as dielectric constant. So once it is defined, click OK. That's over. Okay. And this is about the boundary. Again go to properties, select boundary, click add property, type the name of the boundary as new boundary or my boundary or whatever name you like to do. You type your own name and select the type as mixed boundary. So once everything is defined, click OK and come to the main screen. So now okay, everything is assigned. Everything is defined now. Now you have to assign the definitions to the diagram what you have drawn in the main screen. Okay. Now you have to assign it. So what next? Okay, coming to this one. So now here I need to assign this conductors. Select the line. So keep the mouse here, right click and then press the space bar. Right click and then press the space bar. Now in conductor, here you see that in conductor. So here you mention it as grounded. Select this conductor and click OK. That's all. Again coming to the bottom line, keep the mouse here, right click, press the space bar and select it as ground and click OK. Fine. Now I have to define the space as dielectric. What next? So here is it mentions, that is a green button here. This mentions the gauge. Select it now. Keep it here. Now keep the mouse here, right click, press the space bar and you need what type of blocks. As we said, yeah, mica, nylon, paper, polyethylene or new material, whatever different. So which material you want to fill in between the two plates, that you have to choose. Now I am going to choose my own material at new. Okay, click OK, fine, and so that. The next one is where we have to mark the boundaries. So click the line. So keep the mouse at near the side lines. Right click, press space bar, and select the boundary as new boundary what we have defined already. And similarly for the right hand side also, keep the mouse near the line. Right click, press a space, and in the segment property choose new boundary and click OK. Now everything is defined. So what is you have to do? One thing is we simply forget to save the file. So the next immediate step is you have to save the file as my first FEMM project. This is my first, so I keep it here like this. Okay. Now it is saved. So now everything is saved. So now you have to create the mess. Everything. Now the mess is formed. Once the mess is formed, the problem is ready for simulation. Once again, we recall what we have studied. Once again, we recall it. So how to assign? So select the line and click the mouse button. Keep the mouse pointing near the top line. Right click, press space, and then select it as a conductor. Again for the bottom line also. Similarly, side lines, you keep the mouse near, right click, space bar, press space, and then select the boundary type for right side and left side lines. And similarly, so you have to choose the emblem, green symbol, and okay, place it near the in between the two conductors. Right click and select the type of materials, and once everything is saved, after saving, click the mesh tool to form the mesh. Once mesh is formed, the simulation is ready to the diagram is now ready for simulation. Click the simulation tool. Once simulation is over, you have to go for the analysis. Let us see how it goes. So now the mesh is formed. So here you see the simulation. There is a gear-like structure. So press it. Now the simulation is over. It's a very simple experiment. Also simulation runs within a fraction of a second. Now you can see there are two spexes where this means that you are going to do lenses. Using the lens, you are going to do the indent analysis. Press it. Oh, what? Oh, what a beauty! A beautiful image is coming, and this image shows how the field distribution, how the potential distribution takes place in between the two conducting plates. So this is a beautiful diagram. Looks very colorful, and this is the diagram which we are going to do or carry out analysis. What are the analysis you are going to do? So here there is a node. So select the node and put nodes at between any 2 points where you want to do the analysis. After that, select the line tool, and between the nodes you have draw the line. Anywhere you can, between here and here, here and here, or here and here, any 2 places. Now the line is drawn, and there is a symbol called that points like a graph. Now select the graph. So see, this is the plot types. So here you can draw the plot, that is voltage, magnetic flux density, so normal and tangential flux densities, electrical intensity, normal and tangential, everything you can draw here. Now I want to anything, whatever you want to draw, you can select. So I want to draw the voltage. So how many points and everything you can do that. Okay. Now click OK. Now so you got the graph. So from 100 to the last 10. How the voltage distribution is coming out. So that is as a linear drop in voltage from the top bottom to the lower bottom. So we know that lower line is the ground conducting plate, and upper line is the conductor with 100 volts. This is how the voltage drops takes place. So similarly for any kind of, so using this you can draw. So I want to draw electric field intensity between the two. Okay, go select it. Just this is how the field intensity is there, and this is how it looks. So you can do further analysis using these tools. Okay, again select this one. So now if you put this capacitance like, see how the V and C are voltage and charge are available. You know the C is equal to Q by V. So you can easily find the capacitance value of this construction what you have drawn. Okay, and similarly this is about the energy. So you can choose anything E and P, and this will look about the certain things what is happening in between the entire medium. Now you select this one, the vectors. What are the vector types you want to draw? I want to draw electrical intensity. Okay, draw it. So see how the electrical lines are here, and see this is, click this and show equipotential line. Equipotential lines are there. So the horizontal lines are equipotential lines, and the vertical arrows point the field lines. So we know that the equipotential lines and the field lines impact each other exactly at 90 degrees, and this is what the analysis you have to do. So these are some of the preliminary analysis you can do with that, and similarly you can do many number of analysis. So you can have an analysis like cable, so in which the center you have a conductor, there is a cable with insulation, and this is the analysis of it. And you can do lot of simulations like this in our experiments. Then in that I will help you while you are doing the experiments. Okay, so these are the procedures. Now once again I recall, once the simulation is carried out. Okay, so this we already said. So once the simulation, you have to click analysis tool. So choose the node buttons. So between which two nodes you want to, 2 points you want to do the analysis, you have to decide. Between the 2 nodes, draw the line and use the graph tool and select the parameter you want to plot. So again, using the arrow tool, you can draw the field lines. So these are some of the analysis what you can do it here. So this is all about the FEMM tool, what we are going to use it in our practices in our laboratories. Okay, in our laboratory. So for any queries and discussions, you can always raise it in a class. I am ready to help you. Thank you.